So, good day, everyone. Today, we're going to talk about the common terms that everybody should know regarding artificial intelligence. And the first one is neural network. So, Luca, explain a little bit.
Well, neural network is a tool for performing a learning task, which means
Mhm.
that through data, we are able to use neural networks to extract information from data. And neural networks are the most popular artificial intelligence tool that are now used ubiquitously for classifying documents, uh, understanding voice. Tagging images. So that's really the architecture or the tool that is most common and most popular. And the reason is very simple. While the neural networks in the past were, let's say, a forgotten tool, couple
Mhm.
of years, well, 5 years ago, 7 years ago, they became mainstream when the deep learning revolution hit the community and essentially changed the way people are doing AI. So at the moment, we're not using neural networks anymore, but we're using a much more powerful type of neural network, which is called deep neural network.
I see. Okay. So, for everybody, so neural network was before, and now we're using a much more advanced version, but it's just a matter of the complexity of the network, is it?
Yeah, exactly. The core fundamental structure of the network, it
Mhm.
doesn't change. The scope or the goal of the network doesn't change. Solving a problem, as the ones that I outlined before.
Mhm.
The versions that are now more modern are just bigger and more powerful.
Oh, okay. That makes sense. All right. And the second term is machine learning. I feel like a lot of people, when they hear this, they feel like they know what it is. So it would be great to get like a proper, like informed definition from you.
Yeah, sure. Machine learning actually can be used as a substitute term for artificial intelligence,
Hmm.
although in my view, it's really a subset of artificial intelligence. Some of the techniques that are typically included in the under the umbrella of artificial intelligence are not part of the machine learning let's say subset or community. For instance, in my personal definition is that is machine learning should be mentioned when there is some actual learning. So
Hmm.
when models are trained using a data-driven approach. But for instance, rule-based algorithms and rule-based techniques that I'm not going to define in this episode
Hmm.
are have no learning, so there is no learning involved, but they are artificial intelligence mechanism and artificial intelligence algorithms. So this distinction can be important in some
Hmm.
context, and I would say that now 90% of people in the community says that they are involved to some extent in machine learning research. It is rarer, albeit more common than before, that people are mentioning artificial intelligence.
All right. So the public view, well, I guess for people who don't specialize in this, they would say that machine learning is kind of just artificial intelligence. But from an expert point of view, it is a subset of artificial intelligence with regards that this type of learning actually involves learning. It's not just following a set of rules. Does that make sense?
Yeah, exactly. And rule-based systems are just one of the example that comes to mind when we need to differentiate artificial intelligence from machine learning. But guys, let's be blunt and honest. It's perfectly fine if you are using them interchangeably. There's no problem at all.
Okay, perfect. And for the last term, explainability. Now, I have a little bit of a comment on this. When we say explainability, it sounds very like, it sounds really intuitive. Is it really as intuitive as we all think of it, or is there a more specific
Yeah, well,
definition?
look, Michelle, I'm glad that you inserted this third term in our, let's say, very short vocabulary, vocabulary, because that's really, at the core of the capabilities of AI and machine learning.
Hmm.
The ability to self-explain, so the ability to justify a specific outcome, is becoming of paramount importance for embracing AI. So, for instance, if I am, let's say that we go for a very specific use case. Let's say that we're looking at AI in HR, human resources, and specifically we're looking at hiring. Now, when we are scanning CVs with artificial intelligence, we are dealing with an important decision, taking that candidature in account or not. So there must be some level of explainability. So the AI algorithm must tell us why it took a certain decision, either including or discarding that specific candidature. If we don't have that level of explainability, if we don't understand what the AI is doing with our data, then all the rest becomes much more difficult. In particular, using AI in certain use cases, like for instance, healthcare, banking, or HR, becomes actually impossible because there are regulations. There is a complex process that needs to be dealt with. So explainability is probably among the three the most important term that we define today.
All right. So if I were to summarize that, essentially explainability is important because it gives the people who are creating these algorithms a way to explain how the decisions are made. So it's basically a defense mechanism to anybody that's like, okay, how did you come up with this, right? We don't just trust how the algorithm works, but if you were able to lay out exactly the judgments that were taken into account, then you're able to say, this is how we came to this decision. Yeah?
Yeah, exactly. And we're a little bit out of time, so I think we can close the episode here. Thank you very much, Michelle, for selecting these three interesting terms. I think we're going to certainly do many other episodes on these topics, so that we add more terms to our vocabulary. Thanks a lot for listening, guys, and press that like button if you enjoyed this episode.